Okay. Previous colleagues gave a wonderful introduction about FACEIT and its functionality and its how to build a simple workflow. But for most of researchers, you have your own research stories and you need to develop your own specific research goals. So maybe, yeah, I'm going to show how to use FACEIT to develop your own specific research simulation experiment. So I'm going to build a complicated workflow and also show how to use the visualization apples to analyze your previous data. First of all, I'm going to show how to build a complicated workflow. So I start from the procedure that introduced by Meng and to build workflow by using neural data. So after you design your experiment, simulation experiment, you need to upload the data that you're going to simulate. So the first step to upload the data, I already upload all the neural data. Yeah, I save it in the history. So this is the neural data. So that's you upload that we need to upload. Yeah, included the survey data, seasonal strategy, and the linkage as well, weather data. Second, we need to build the workflow. Yeah, I already built it over here. So I built two workflows. They are neo simulation with adaptation and without adaptation. Let us look the without adaptation case first. So actually, this workflow is basically from the simple steps just showed by Meng. So I just repeat the procedures he showed and repeat it again, and which include historical scenario and current scenario and different system scenario simulations. So it discuss 12 or more than 12 simulation style and simulation strings. But for this complicated workflow, the one important thing that we need to do is the annotation. This annotation means we can we know what the workflow this line doing in the future. For example, for this apples, we just annotate that it is mean this is historical scenario, and we also give a new name. New output name. So when the simulation is done and it is listed in the history, so it has a new name, history. So we will know this is come from the historic simulation. So for all the apples, I just rename it. Yeah, this is AgMIP historical disaster, and so for each of the line and each of the apples, I just annotate it with different name, and let us it can remind us in the future so what we are doing. Okay, so after the workflow is built, we can save and simulate. Before simulate, we need to identify which data we want to use. For example, for this historical, we just select historical survey data and the historical weather data, and also the doom and the linkage. And for all scenario, we need to repeat the procedures. And after you finish your selection, you can make it run. I already run it, so already saved in the historical. So this is all the simulation for the neural data without the adaptation. We can say that's all the simulation results. So we have different names. This is a historical data and cartographical data. Yeah, so it will save in our computer. So this is how to build a complicated workflow. And the next thing I want to show you how to use the FACEIT visualization tools to easily analyze your simulation outputs. Because after many simulations, we may need some tools to analyze it. In RIA, we have three visualization tools, which are standard plot apple. This is a plot to analyze the AgMIP output by box plot and CDB maps, and also the plot climate scenarios. That is to plot the climate information based on your uploaded weather data, and also the plot AgMIP relationship. So I will show it each by each. So this one is the so I'm going to show this one. So this one we can incorporate this apple in your workflow, or also we can run it standalone after you make your all simulation done. So for example, I already have all the simulation done, so I can easily make it to run. So for example, I want to show the combined result. So I want to show the simulated historical year. I want to show the output between different scenarios for the simulated year. So I want to show the box plot. So I add a new AgMIP output file. So for example, I have lots of output file. I just select 2. So for example, I select history result. I give a name, history result, and also select another one, history absent. So I can generate the map. So this apple has 2 outputs. One output is to combine 2 AgMIP outputs together into one AgMIP output, and another one is the plots. So you can say the plots. So that's the difference between desired and the absent by simulating the historical survey data. And we also can generate different types of maps. For example, for CDF maps, that show the probability of simulated yield or any other simulated outputs. And also the second visualization tool is the plot climate scenario. That's just to show the to present the comparison of the different GCM with weather data. In this case, I just selected several. So I want to see the maximum temperature between different GCM. So I add a future weather scenario. Oh, this is also, first I need to switch to the data sets. So I switch here to narrow date and click the plot. Select the relative or also absolute. You can see the difference. Yeah. Add a future scenario. Okay. And another one. For example, IE, and add a new baseline scenario. So we can execute it. It takes a while because in each weather data they have many sites, more than 10 sites, or in some cases they have 100 sites. So that takes a while to finish. But I already have the result in the plot, so I can show it in the plot history. So here's the results. For the comparison of different GCM with the baseline historic data. The last visualization tool is the plot AgMIP output relationship. This has because all the visualization tools are interactive and friendly interface. So you can select a different variable you want to plot and different outputs or inputs file for this case, we can do some correlation analysis between models and between variables, whatever you want. So, for example, I want to show without, I want to plot the output without adaptation. So, for example, for the x variable, I want to show the simulated nitrogen uptake, and then this I want to say. So simulated yield. For grouping, the grouping does mean you can plot by different grouping methods. For example, I want to grouping by cultivar name. So let us try. Yeah, it's finished. So yeah, there's only one cultivar in this case, so can see the relationship between simulated nitrogen uptake and the simulated yield. And if we want to say different the responses with in different soil type or earning between crop models, we also can say it's different. This is for different models and also soil, yeah, maybe soil type. So there's lots of this kind of maps. This different. This is different soil type, yeah, and also crop models, and also, yeah, we can see different cultivar and different soil type. And yeah, if we want to say the difference between output with adaptation and without adaptation, we can combine, we can copy the history. Yeah, we can copy, extract, copy data sets and combine different history together and do the combined analysis. So that's very powerful utility, yeah, of physics.